Hello and welcome. Interesting video today, building an intraday stock price database using Python and a pinch of SQL/SQL, whatever you want to call it. Now, intraday stock price data, quite hard to get as opposed to cryptocurrency price data. There are basically two free sources, that is Finance and Alpha Vantage. Now, I was already going over using Finance in the past. So in this video, I'm going over using Alpha Vantage, but if you prefer Finance, the concepts can be applied as well. The data sourcing part is just a bit different here. All right. So what we're going to do is we're going over data sourcing. So connecting to the Alpha Vantage API, sourcing intraday data, then storing that in a SQLite database. And then we're also running some queries on that database. Let's get started. So as you see, 3 libraries needed: pandas for data handling, SQLite to connect and to create a SQLite database, and request to interact with the API. That's already it, library-wise. Now, for using the Alpha Vantage API, you need an API key. I know it's annoying, but in this case, it's super simple, and you didn't hear that from me, but you don't even need a real email address. So you go on this link, I will link it in the video description. You just name anything here, then you just provide an email, and then you click on that button and you directly get this API key. So it's really conveniently designed here. So all good. You can even use mine if you want, but the API limits on the free API key on Alpha Vantage are strict. So I think it's 25 API calls a day. Now, how do you interact with that API? First, you need to define what exact data you want to pull. In our case, we just want to get the most granular price data for a given symbol. So I'm just going to copy paste the URL for that into this notebook. So let's go over the URL string. That is just a copy paste from the Alpha Vantage API documentation with some amendments for my requirements. So this is just the base URL. Then we have a query. Then we pull intraday time series data for IBM on the 1 minute interval. Then I post my API key here, which, as said, is easily generated via here. And then you also define the output size as full. So I'm going to link that into the video description so you don't have to type that for yourself, or you just copy paste from the API documentation yourself. So that is the URL you gotta define, and then you provide a GET request. So simply define R as requests, GET, then provide the URL. So you just tell the API, hey, I want to get intraday data on the 1 minute interval for IBM. So with that, you're getting a feedback on the R, usually, hopefully a 200 feedback. That means it contains data. So the API GET request was getting through. Now what's inside there, we just do a JSON transformation here to get it in a JSON format. And this is looking like this. So you see a lot of data here. For you, only relevant is the time series data on the 1 minute interval. So you see it's stored here in a dictionary format. So to get the time series data for interval on the 1 minute interval, you just can use e.g. Let's store that somewhere first, easier to process then. So then we take data get, and as you saw, time series 1 minute in parentheses it was, and then you will only get the time series part, which is the relevant data you need. So doesn't look that lucid yet, but we'll take care of that. So let's just transform that into a data frame. So we're getting a better overview of that. So just pandas data frame function on exactly that. And then you will see that you're getting a data frame like this. So it looks pretty off for for my preferences. So you have the timestamp as the columns and the columns as the rows basically. So what you can easily do is just transpose this data frame to get it in the good old structure you are familiar with working with time series data. And that is simply using a T, which is transposing a given matrix. And then you're getting this beautiful, wonderful data frame with time series data. So you see the sorting here is a bit off. So we have to take care of bringing that in the right order here. But you see we have a timestamp index on that data frame, open, high, low, close, volume, columns here. Column names could be amended, but we'll do that in some seconds. So you see how you can source the data. You see that it's going, I think that's roughly 1 month back. So a bit far more out than Y Finance, which is only going 1 week back on the 1 minute time frame. So that's already pretty nice here. What you also see, and that is a difference to the Y Finance data, you also see data after market close. So you have like extended trading periods for instance, electronic exchanges, where you have trading after, in the American case, 4 p.m. here, right? So you see that you're getting more data as you would get from Y Finance. Of course, you can limit those data if you only are interested in the official opening hours, which is going to 4 p.m. in the NASDAQ case. Then you just filter the data out and just take the data until that data point for any given day. I'm not doing that here, but just that you know why you're getting more data from Alpha Vantage than you would get from Y Finance. Okay, so you know how it works with the data now. Let's bring a bit structure into that and create a function which is doing all these data manipulations for us. So let's automate it, factorize it a bit. So let me just copy paste from other screen, and we are going through this function step by step so you understand what is going on in this function. So keep in mind what we just did. Let's get rid of everything here for now, also the URL, and just copy paste the function from my other screen. So what is this doing? Fetch intraday data. This function is taking a certain ticker, let's say the IBM ticker. Then is taking our exact same URL, but just formatted as an F string so we can pass strings or pass parameters into that. And what we are doing is to pass a given ticker when we call this function. So for instance, this could be IBM, so it's being ticker IBM here. Standard interval is 1 minute, so this is going to be posting 1 minute interval here. Then we still need to fill in the API key. I missed out on that. I simply forgot to do that. So let's just put in our API key here. And then output size equals false. So this is the exact same URL you just saw, then the same story as before, defining a response variable. I called that R beforehand, just that you don't get confused why it's named different now. Doesn't have a reason, it's simply other variable name here. So you can call it R response, whatever you want to call it. You can call it giraffe, you can call it elephant, but R or response is the common variable name for those requests responses. Now it's transforming to JSON, then there's just a print statement. So you see what the data is, how the data is looking like, purely optional. You can just get rid of it, maybe to have a more lucid output. I'm just getting rid of the comment here, the print statement here with a comment. And then I have defined time series, and that is exactly doing what I just did. So just browse for the time series data for the 1 minute interval. If that is a 5 minute interval, it's called 5 minutes. So that is why it's being flexible here. And yeah, if I don't have anything herein, so I don't have time series data, then I want to get a feedback, no data returned for a given ticker. And this function just should just stop and return none here. But if I have time series data, then I want to define my data frame. So I'm not defining, but I'm transforming my data frame as we just did by providing a data frame function, then passing this dictionary format into the data frame. Then we have this off view of columns, as you just saw. So we are transposing it. So we have the timestamps as the index and the columns as the columns. Now the index name should be timestamp, and then we rename those columns. You saw the names were just a bit, inconvenient. So 1 open, 2 high, 3 low, 4 close, and so on. So we're just keeping it as simple as possible and as lucid as possible. So we're just renaming the columns. Then resetting the index. So we have the index as a column value. And what we need to do beforehand, this is a logical error here. We need to sort the index before we reset it. That's my fault, sorry for that. So we're sorting the index. You saw that the data frame was not sorted by the timestamps, so we want to have it sorted. So we have actually correctly sorted data by the timestamp. Then we reset the index. That is simply due to the fact that I want to have the timestamp value as a column value in my database and not as an index. And then finally, just that you have it scalable, so you want to store more than one ticker in the database, you provide a ticker name, and that is just the ticker, in our case IBM. So a lot of talking. Let me show you what this is looking like, or what this does when we call it. That's always easier to understand. So fetch intraday data on, say, IBM. Interval we don't have to provide, as it's a standard argument here. So this is looking like this. So perfectly sorted data starting 25th of July, 4 o'clock, and then goes until the last available data point. Makes sense, right? Today is Sunday. Last trading hour was 19:59 on Friday, and that is, as said, the extended trading. So for Yahoo Finance, you would get 15:59 here instead. And you see quite a low volume on, it's 1 minute granular data. So there's a lot of interesting things to check out here. So you could, for instance, just plot the close and see for any anomalies in some certain time periods. So for instance, if you just take this and store that as a variable, and then df close plot, set the index to timestamp, so you have a meaningful chart here, then you would see nothing because I messed up here. So df set index timestamp. Let's see what we got here. Close probably not correctly formatted here. Because here currently it's an object, so you just transform it to float and then plot it afterwards. So you see, you have the close price plotted intraday granular for IBM here. All right. So this is how the data is looking like, but this is something we solve on database level. So you don't have to do that every time. But if you just pull the data from the API, it's coming as string values. It's how the API is working. So you need to do a typecast here. Sorry for that. All right, so data sourcing part from Alpha Vantage, check. Now, what is the next thing to do here? Next thing to do is to establish an SQL connection with Python. So let's define connection, SQLite 3, connect, and then you need to provide a database name. Let's just call intraday stock prices.db. This is creating a file named exactly like this, and this is where your data is getting stored. Now to interact with that, we define a cursor, set up the cursor here, and this cursor we can execute or take to execute SQL queries. So the first query we actually got to do is to create a table where we store exactly those values you just saw. in the data frame. So cursor execute, and then you need to provide a create statement, and to save some time I will just copy paste that from my other screen. It's very straightforward. So you just have create table. That's simply the standard SQL expression to create a table if it's not existent, and then you name that somehow. So in this case, just name it intraday prices. And then you have the ticker as a text value, the timestamp as a text value. You can also work with a datetime value here. In this case, I decided for using text value on the timestamp. Then open as real, high as real, low as real, close as real, and the volume as an integer value, because it's always provided as integer values here. So this is creating a table, intraday prices, in your intraday stock prices database. So let's execute that. Getting feedback that we have a cursor, and then we also want to commit what we just executed. So con.commit. So we have created a database, intraday stock prices DB. You will see that file in your folder where you're currently operating, and you have an intraday prices table with those defined columns. So there's currently nothing in the database, but you have set up the database and the table, so we can now begin to fill that database. Before doing so, we need to take care of one issue, problem, or thing we just need to take care of, and that is if you want to write data into the database, you always want to make sure that you don't have any duplicates in the database. There are a ton of approaches to achieve exactly that. My preference is always look for the maximum of, e.g. in our case, the timestamp values, and just append data from the API which is after that max timestamp. With that, you will never get data duplicated in your database, and you are taking care of it efficiently. So how can you do it? You just max on the timestamp value from this intraday prices table for a given ticker. So it could be different across different tickers. If you just use American stocks, for instance, you most probably never run into that the tickers have deviating max timestamps, but it could happen if you go on global stocks. So you have a German close, you have a US close, you have a, I don't know, Singapore or whatsoever close. Now, the function to achieve that, I'm also going to copy paste. So get latest timestamp for a given ticker. So as said, just a max query on the timestamp from the table we just created, where ticker is like the provided ticker for that function, and then you just execute the query on that given ticker, and then fetch the first available entry. In that case, that's a technicality. So of course there's only one max, but it is coming. You can execute that fetch one, and you will see that you have to index for the first available value here. So let's actually do that. Get latest timestamp for, let's say, IBM, and we're not getting anything. That is because there is no latest timestamp. Why? There is no data in our database, so we are not getting anything here. But we've set up the function to be able to query for max data, so we can store data to the database without having to worry that we have duplicate prices or duplicate rows in the database. Next up, so let's actually define this one from scratch here. So store data to database. So this taking data and a latest timestamp as an input here. And as you might already guess, that this is being taken care of by this function. Now, how does it look like? If I have data, I want to have the data from the fetch intraday data function. So this input is going to be provided by this function. All right. So the data we treat as the data frame we just saw. All right. So if I don't have anything from the API, so if data is none, then I want to get a feedback that there is no data which I can store. But if I have existent data from the API, so if data is not none, then I want to check if I have the latest timestamp. And if I have a latest timestamp, so if my latest timestamp variable is different from none. So in this case, as you saw, we have none, so we don't have a latest timestamp. Then we just append to the current table. But if we have a latest timestamp, so if latest timestamp is containing anything, which is the case after you've imported the first data, then you want to check for the data coming from the API and filter it only for data after the latest timestamp. All right. So data equals data indexed for the timestamp column. Timestamp larger the latest timestamp. All right. So you're just getting data from the API and filter it for the latest timestamp in your database. And with that, you avoid duplicates. Simple as that. Now, if not data empty, that is, if the data from the API is coming, you wanna append it. All right, so if you, let's say, if you just get this here and you have the max timestamp, this will be empty because there is no data after the max timestamp and there is no new data in the from the API. That is, for instance, today the case, because today is Sunday. You won't get anything in the database because there is simply no new data. It will only be triggered initially when there is no data in the database. So if not data empty, so if you actually have data which is newer than the latest timestamp, then you just want to write to SQL. And you want to write it to the intraday prices table. Provide the connection, which is just your cont variable. And if that table exists, you just want to append. And you set the index as false. Now, you want to have a feedback. So data for, and then whatever ticker you've imported. So data ticker. Then just to only see the ticker name. Stored successfully. So you have a feedback. All right. So this is your data import if you have newer data than the latest timestamp here. Now, if not, you don't have new data. No new data to store. As explained, because there is simply no data after the max timestamp. But what if data is not known? If data is not known, then you have no data to store. No data to store because there's simply not coming anything from the API. All right. So this function is storing your data to the database, checking if you have new data from the API, if that data from the API is newer than the max timestamp of your data, and it's just importing data whenever that is the case. All right. This is a very important function to store data to your database. So next one, we will import data to that database. So let's do that in a main function. So let's just import for a couple of tickers. So tickers could be, for instance, Microsoft, MSFT, and what did we take? IBM. And you can extend that by how many tickers you want. But remember, you have an API limit here. So don't overuse that I heard there are ways to get around it, but it is violating the terms of service, so please don't do it. So for ticker in tickers, we wanna get the latest timestamp. So latest timestamp is defined as get latest timestamp of the given ticker. And then simply we have data defined as calling the fetch intraday data on the ticker. Then you have the data from the API. And then we call our function store data to database. And you can imagine data, we're pulling data from the API and the latest timestamp from the database. As simple as that. So if name main, then you want to call main. And whenever I'm doing that, I'm getting some error because I messed up at some point. So fetch intraday data is not defined. Fetch intraday data is not defined. Fetch intraday data. Fetch intra, yeah. I mean, you have to be able to read and write. That's a main requirement for being able to code. So correct the typo. And now this is running. So let's see what we are getting here. So data for Microsoft stored successfully. Data for IBM stored successfully. All right. And now if you execute that again, you know that you don't get data from the API. And I hope I don't hit my API limits now. So let's execute that once again, knowing that we have data now. And you see we're getting feedback, no new data to store. So everything went better than expected, or everything went as expected. Now finally, let's do some querying part stuff here. So you know how you can actually pull data from that database to utilize it. So yeah, I mean, let's do it in a function. So we find a query data. This taking a certain ticker, the start time, and the end time. So if you're interested in a certain time interval here, and this you just have to define the SQL query to get what exactly you want, and that is very straightforward. So you just, let me copy paste that from other screens so we save some time. So select, I need to be an F string here so we can pass parameters. Okay, that should do the job. So select all rows, or so all columns from intraday prices, so our data table, where ticker is the provided ticker and the timestamp is between the provided timestamp and the provided end time. And then just use pandas read SQL function here, provide the query and the con variable, and then we return the data frame. So we have df equals query data. Let's pull for IBM, and then just, I don't know, a good one. So let's just take only the Friday data. So I don't know, from 0 to what did we have? 1995 or so. So that should only give you the Friday data. So let's take a look at that. So you see we have the Friday data in here. Right? If you want to be on the safe side, you should maybe sort this timestamp once again. So timestamp. Yeah, I'm thinking about a better way. Maybe do it in the query directly. So order by timestamp descending. So now you have it, the newest one on top and the earliest one on the bottom. If you want to have it other way around, you can just use ascending here. Whatever you want to have here. And then you can plot as I did in the beginning. So df set index to timestamp, close plot, and then you have plotted your intraday stock price data for IBM. So you can easily just pull data for the symbols you have stored in the database and play around with that. So here's already something I would take a very close look at, but probably some, I would guess, some liquidity issue out of the normal trading window, so the normal exchange hours. So somewhere out of the trading hours, some liquidity issue. But this is something you would have to take a look at. Maybe also wrong data from the API in the worst case. So be cautious with the data. They might contain wrong data points. All right, but I think overall this is super nice to use. Now, what should you do with it? Of course, you obviously have to run the script regularly. So let's say this is going back 1 month. So you want to call it or run it at least once a month, and then you just stack up on the data, and then at some point you have a very mighty intraday stock price database with going back multiple months. And yeah, I think that's nice to have, and you can build up on that. So as said, you can also do that with Y Finance. Then you have to run it every week and stack up on the data. But I think that's it for this video. I hope this was interesting, helpful. And by the way, just whenever you're done with your database querying and everything, then it's a good practice to close the connection in the end. All right. So yeah, thanks a lot for watching, and I'm looking forward to see you in the upcoming videos. Cheers. Bye.